Hi everybody, this is a lesson on chain rule, of the differentiation. So what exactly is chain rule? So if you kind of understand some of the simple derivatives, I'm going to demonstrate you both as quickly as possible. What's difference between chain rule and normal differentiation? So chain rule is basically which is helpful to differentiate composite of the functions. So what exactly we do is, so suppose if I'm asking you the derivative of following functions. So if you have been derivative of x to the power 2, derivative of x to the power 2 is 2x. Now derivative of sine x is cos x. You don't have to write on dy by dx because that's a common mistake students make, like dy by dx into x squared. Like it doesn't make any sense. Like you're finding derivative of x squared. Now d by dx, so if I'm asking you e to the power x is e to the power x. D by dx of ln x is 1 over x. Derivative of let's say cos x is negative sine x. So it's not like, it's not clear that every time you're going to get derivative of only these kind of basic functions. You can get some of the derivatives like this. So you have to differentiate. Suppose what do we do is you have to differentiate x squared plus 10x plus 5 to the power of 2. Now first thing that comes to your mind is you would like to open this bracket and get the differentiation done. But why do you want to do that if you have a shortcut available? So if I wanted to differentiate this, now this is a composite function. Like basically, if I plug in place of this x, I plug this function, I get this composite function. So how do we deal with such problems? So suppose if I have to do any particular function, if you have derivative of x to the power n, it is n times x to the power n minus 1. This is the derivative of x to the power n. But how about if I want to do derivative of some function to the power n minus 1? Let's say some function to the power n. How do we do this one? So the only one thing you have to consider is you have to differentiate as if you're differentiating normal function. So n times fx to the power n minus 1 into f dash x. This is the only thing that you have to do is you have to multiply with the derivative of inside. So if I have to show you out this with the example that I've taken up, so if I'm differentiating x squared plus 10x plus 5 to the power 2, my function is out here. This is my function. So this is my derivative. I want to find out. So this is like a f of x. Now how do I do? So first you can see that I'm doing nothing to this fx in this step. So you will do 2 times x squared plus 10x plus 5 to the power of 1, because 2 minus 1 is 1. Just you have to do one additional step is into derivative of this thing, which is 2x plus 10. So that's your derivative of this within a single step you get. And if you go on expanding, I never know that you'll get the expansion correct, first of all. And second one is you might go wrong and might take more time. Here is another example. So suppose if you want to kind of differentiate, this is example 1, my example number 2. If I want to differentiate, let's say 4 over, I want to differentiate 4 over x squared minus 3x to the power 20. You are thinking to expand 20? God bless you. What are we gonna do is that if you have to differentiate this, you first take this as 4 times x squared minus 3x to the power of negative 20. Hope this is clear. Because if you have any indices down, it can be taken up and can be written as negative power. Now if you want to do derivative of this, now this is like your function and this is your power n. So your dy by dx is gonna be, look at this result, function out here to the power n, so n function to the power n minus 1. So this is gonna be 4 times x squared. So first of all, keep this 4 as it is and multiply with 20 because that's my n. Then x squared minus 3x to the power negative 20 as it is minus 1 n fx to the power n minus 1 What do we do next? Into derivative of fx, which is 2x minus 3. That's your answer. So it's going to be negative 80 x squared minus 3x to the power negative 21 into 2x minus 3. And if you simplify this, it's going to be negative 80 2x minus 3 over x squared minus 3x to the power 21. Hope this helped you understand the power differentiation using chain rule. Now what happens is that if you get something like this, suppose if I want to do differentiation of if I want to differentiate, one of the favorite example is for the examiners is differentiating sine squared x. Let's say I want to differentiate sine squared x. Let's see what do we get. So first of all, I can't figure out because I know the derivative of sine x is cos x out here. But how do we deal with a sine squared power? Now what I can do is I can write down this the same thing as derivative of sine x to the power 2. And now you try differentiating it. So first of all, you differentiate the power. Now this is like my function out here. This is function. So it's going to become 2 times sine x to the power 2 minus 1. First I'm differentiating power, touching not sine. Don't change sine into cos here itself. Into derivative of sine here, you do in the next step. So which is sine x derivative is cos x. So that's your answer. So the answer is 2 sine x into cos x. Hope this helped you to understand basics of power rule with chain rule. Now let's look at some of the more examples for chain rule. So if you want to kind of find out, let's say if you want to solve for derivative of, let's say you want to solve for derivative of sine x plus 4 to the power of 20. I want to solve this one. So first of all, what you're going to do is if you want to try this sum, you can pause this video and try it. In fact, to make it difficult, I'm trying this, let's say 2. So if I want to differentiate this one, what I'm going to do is, so first you differentiate the power as it is, like, what it would become is 20 2 sine x plus 4 to the power 19 into derivative of inside thing, which is 2 cos x plus 0, because derivative of 4 is 0. So that's going to become 2 sine x plus 4 to the power 19 into 2 cos x. This is the derivative of this. This is related to power rule. Now, in case if you try some more examples of power rule, now here are some more examples. You can try these questions. So first one is, let's say you want to try 4 over x squared minus 3x square root. All right, so let's you can pause this video and try this. Here's the solution of this. So first of all, if I want to differentiate this, what you do is you first write this as, so you can write down this as 4 times x squared minus 3x to the power of negative half. Okay, now what you do is, this is my function. So first of all, you differentiate normally. So it's going to become 4 times negative half as it is n x squared minus 3x to the power negative half negative 1, because n fx to the power n minus 1 into derivative of x squared minus 3x, which is